Finding the exact value of cosine of 75 degrees. First thing to note is that since you want the exact value, you want to go ahead and use your formulas. Give me two angles, which are special right triangles associated with special right triangles that add up to 75. In this case, I'm going to go ahead and use 30 and 45 degrees. From the formulas, this is equivalent to cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees sine of 45 degrees. And again, this is a formula. Since I'm going to be using 30 degrees and 45 degrees, I'm going to go ahead and sketch these two angles on the side. This is 30 degrees. This is 45 degrees, and label it accordingly. This is opposite 30 is 1. This is the square root of 3. This is 2. Opposite is 1, 1, and then the square root of 2. Again, these are your special right triangles. Now, go ahead and substitute cosine is adjacent over hypotenuse. So I look at 30-degree triangle. Adjacent is square root of 3. Hypotenuse is 2. So I have the square root of 3 over 2. Cosine of 45, I jump to this triangle, is going to be adjacent over hypotenuse is 1 over, or divided by square root of 2. Sine of 30, that's opposite over hypotenuse, which is 1 over 2. Sine of 45 is 1 over square root of 2. I'll go ahead and simplify this. I have square root of 3 times 2 square root of 2 minus 1 over 2 square root of 2. Dealing with fractions, I have square root of 3 minus 1 in the numerator. Common denominator is 2 square root of 2. Last thing to do is to just simplify this a little bit further. I want radicals in the denominator multiplied by square root of 2 times square root of 2. I'm going to go ahead and distribute this since there are two terms in the numerator. I have square root of 3 times square root of 2 is the square root of 6 minus 1 times square root of 2, I get square root of 2. Now here you have square root of 2 times square root of 2 is 2 times this 2, I get 4. So this is the exact answer.